Okay, so now that we looked at number 4, we're going to take a look at number 5 and maybe go a little bit faster. Now that you understand the process of how this whole thing works, we just have to basically work through a couple and make sure you understand. So the first thing we have to do is rational root theorem because we can't factor this. So our rational root theorem identifies the constant as the p and identifies the lead coefficient as the q. We have to write down the factors of each of these and then put it in a ratio. Our factors of p are what makes 2 when you multiply, just plus or minus 1 and plus or minus 2. For our q, what makes 3 when we multiply? Just plus or minus 1 and plus or minus 3. So when we go to write our p over q ratio in order to do the possibilities, this is going to be super small. We're going to take our 1 and 2 and put it over 1, which means that you're just going to get plus or minus 1, plus or minus 2. That's from these two over 1. And then we're going to take these two and put them both over 3. So we'll have plus or minus 1/3 and plus or minus 2/3. Those are all of the options. So this is a cubic. It has at most 3 roots, and these are all of the possible real roots that this cubic can have. So our job now is to figure out one of them. Any one that works in this polynomial we can use to help us find the depressed polynomial and factor. So I'm going to start with x equals 1, plug it in, and see what happens. This is 1 to the 3rd, which is 1, times 3 is 3, minus 1 squared is 1, times 2 is negative 2. So this is 3 minus 2 is 1. Minus 7 is negative 6, minus 2 is negative 8. This is not an option, not a solution. So we got to try another one. So I'm going to do negative 1. Be careful when you're doing this that you're following order of operations, because if you don't, you're never going to get these to come out right. Okay, order of operations says you've got an exponent before you multiply. So I would do negative 1 to the 3rd, which is negative 1. Negative 1 times 3 is negative 3. So I'm just going to keep that on the side. Then I've got negative 1 squared is positive 1, and positive 1 times negative 2 is negative 2. Then I've got negative 7 times negative 1, which is positive 7. And I've got minus 2. Boom, I got 0. Perfect. So this is a solution. When we get a remainder of 0, that means that we have a solution. So I like this one because we got to it pretty fast. Here's our solution, first one. So we're going to take our solution and we're going to put it into our synthetic division model. So down here, x equals negative 1 goes on the outside. Is it missing any terms? Let's see. We got an x cubed, x squared, x, and a constant. So nope, it's not missing any terms. So I'm going to put 3, then negative 2, then negative 7, then negative 2 again. And I'm going to bring this down and get started. I bring my 3 down. 3 times negative 1 is negative 3, and I add. That gives me negative 5. Negative 5 times negative 1 is positive 5. I add. I get negative 2. Negative 2 times negative 1 is positive 2. I add, and I get 0. Now, I know that this is supposed to give me a remainder of 0. And if you do synthetic division right, this 0 and this 0 have to match. Because I don't really care about this now. I already know that it's a solution. What I need is the depressed polynomial. I need the stuff before it. I need this guy. Okay? And this is going to give me my depressed polynomial. Which is 3x squared minus 5x minus 2. And I know it's an x squared because I started with a cube And when I do synthetic division, I have to subtract 1 off of the highest exponent and start from there. So that's why that's a 2. From here, I'm going to be able to factor. So what I'm going to do is I'm going to do my magic X method that Miss Meek taught us. A times C, 3 times -2 is -6. It's got to add to -5. So factors in -6 that add to -5 would be -6 and +1. But the coefficient is 3. So I have to divide this one by 3, and I have to divide this one by 3. And those are my factors. So when I factor, I'm going to X. This is -6 over 3. That's a -2. And this is an X plus 1/3. These are factors. But now I'm going to solve it. So I'm looking to set it equal to 0 to solve for the roots. So if it's X minus 2, then my answer should be X equals 2. That's a solution. The next one, if this is X plus 1/3, I'm going to have X equals -1/3. And that's a solution. Now we're going to double check and make sure that they're on our possible list. So looking at our possibles, do we have a +2? Yes. And do we have a -1/3? Yes. Those are our possibles. They made the cut. They are correct. Here are my 3 solutions to my polynomial. Now I have enough time and enough information to sketch. So I'm going to pull this up a little bit so you can see more. Sketching time. What do we need to sketch? What are we working with? What degree is this thing? Well, up here, this is a 3rd degree polynomial, which makes it a cubic. My A value is positive, which means that we are going to have something that looks like this. For my M behavior. And the other thing I'm looking at is our y-intercept. Our y-intercept is 0, our constant. And our constant in this problem is -2. And lastly, our x-intercepts, which we found already. Those are all of our zeros. I highlighted them. We've got 2, -1/3, and -1. 2, 0, -1/3, 0, and -1, 0. Okay, so that's all of the information that we need in order to sketch this function, sketch this polynomial, this cubic. So my y-intercept's at -2, so maybe like right here on the y-axis. I need an x at 2. I need an x at -1. And then I need an x at -1/3. So that's real close to 0. Because this is going to start down and it's going to scoot up and the M behavior is going to be up here when we're done, we have to start down here. Oh, I'll do it in a different color. I'll do it in orange. We're going to start down here. We're going to go through, scoot and come down, cross the y-axis, and come through here. So there's what your sketch will look like for this polynomial. For this one, since we couldn't factor it right away, we got our 3 solutions and we sketched and solved.